So I'm going to be talking, as Terry said, about the rise of cloud native in particular and its relationship to in-memory computing and in delivering digital transformation. Just briefly to introduce you to 451 Research for anybody who hasn't come across the organization before. So we are an industry analyst firm. We are now in our 20th year. We are actually located over in the States, but many of the founders actually initially from the UK, so we've got a good presence here in the UK as well. A couple of hundred employees, around 1,000 clients, and we cover around 2,000 technology and service providers through constantly updated written research and data, some of which I'll talk you through in this presentation. So some of the things I want to talk about here, first of all, cloud native, what it is, what it means, what the implications are, and Nikita did a great job of setting that up, in particular then cloud native and as it relates to data and analytics. And I'll give you a brief update on some that we presented last year, specifically about HOAP, or HTAP. It's HOAP we prefer, as I say, a little bit perhaps more optimistic, but it's our terminology. But a quick update on that in terms of the adoption and very much fitting in with the trends that Nikita talked about. So in terms of cloud native, this is a term we see increasingly being used by the vendor community, obviously the analyst community, the end user community as well. And we as an industry have a really bad habit, and as a member of the analyst community, I take some responsibility for this, a really bad habit of coming up with these new terms and technology which are ill-defined, and you talk to different vendors and users and you get a different perspective on this. Fortunately, cloud native is not really one of those. I mean, obviously, depending on which vendor you're talking to, you get a slightly different perspective in terms of the area of technology they're interested in. But we've already seen, the emergence of the CNCF, the Cloud Native Computing Foundation, and the advantage of that is there is this definition, for pretty much from not quite day one, but the early stages of cloud native. And I don't expect you to read this, I'm not going to read this out, but what I will do is just pick out some of the sort of key terminology and trends, because I think even if people use slightly different language to describe, either what they're doing from a product perspective or a deployment perspective. These are some of the key trends that we see that are common across different cloud-native initiatives and products and services. So we're talking essentially about scalability. We're talking about dynamic environments. Obviously, we're talking about cloud, be it public or private cloud. In terms of the underlying architecture, we're talking about loosely coupled systems, loosely coupled architecture, which is designed specifically to be resilient, to be easily manageable, and importantly as well, observable. We're talking about automation and automated infrastructure, particularly related to provisioning, and we'll talk a little bit about that. And then the reason that's important is because it needs to be, or is designed specifically to respond to change, the changing business requirements, the changing competitive environment, changing application requirements. Also, though, I think when a lot of people talk about cloud native, they're actually talking about some of the core technologies. And some of the underlying trends are kind of a given, and they're actually really talking about the technology. So we see cloud native being exemplified by things like containers, service mesh, microservices, immutable infrastructure, declarative APIs. Interestingly, serverless, not on this list particularly, but we see that as being a key technology as well. When we are surveying our end user base, our end user, we call it the 451 Alliance. We work with end users. They take part in surveys and interviews with us, in response to which they get free access to our research. And we see there is a range of different technologies that are being used. And I think one of the key questions we get, obviously as some of these technologies emerge, well, does serverless kind of push containers out of the way? In the same way we saw a lot of focus for a while on, well, containers are the new thing. Does that mean VMs are gone? And we definitely don't see it like this. So clearly there are multiple technologies that are used for different purposes. And we see it, as you can see, it's more of a spectrum. There is the less abstract to the more abstract. Obviously the more abstract end of the spectrum, things like serverless and service mesh. Less abstract containers, microservices, and then almost further off to the right, left, from your perspective, I suppose, you'd see obviously virtual machine environments and then more traditional architecture. And we see, the definite growing interest in cloud-native technology in general, and containers and serverless computing specifically. So this is some data that's taken from what we call our Voice of the Enterprise Digital Pulse. So we do multiple surveys in specific areas of the market, and you'll see some of those specific technology areas. Digital Pulse is a survey which runs kind of across the board, across multiple respondents in different areas, more of a higher level perspective. And one of the key things we always ask there is about IT priorities for the given year. And as you can see, so these are predominantly though IT user respondents. And containers, container management, fairly well represented there with 22%, serverless a little way behind with 11%. Probably hasn't escaped your attention that the top two, data analytics, tools and platforms, and machine learning and artificial intelligence. And I'll talk about, sort of how those two, cloud native and data processing and analytics fit together as we go through here. So it's, relatively early stages in terms of these technologies. And we see that as well if we ask respondents specifically about their use of these technologies. As you can see, containers, container management currently in use with about 30% of respondents. Serverless in use with about 19%, and then a healthy sort of group of respondents who are looking to take advantage of these in the next year, 2 years, or even 3 years. But still, at relatively early stages. And we definitely see that it is companies sort of what we call, obviously on the leading edge, early adopters that are ahead in terms of adopting these. If you look specifically at that group, you see these percentages increase quite rapidly in terms of those that are in use already. And we also see that another way of looking at that is how organizations are developing software to take advantage of cloud native or cloud enabled architecture. And we see that a significant proportion of those are doing so internally at this stage. You see 34% are doing most, if not all, of their development internally in relation to cloud native and cloud enabled software. So very indicative of that kind of early adopter mindset and status. Obviously, as we see greater adoption, we expect more mainstream enterprises obviously to be looking for more packaged applications, packaged software that will be delivering on the same benefits. And some of the reasons that organizations are doing this, as you can see, the top just under a third are doing it specifically to design the development. And I should say this is coming from respondents who are already developing for cloud native. So this isn't about what they aspire to, this is what they're actually doing. Designing it to run effectively on any cloud environment. Obviously with 30% running on a specific public cloud environment is not far behind, and we obviously see a lot of organizations have started off with a commitment to a specific cloud provider. But as that has evolved, the overall plans and the trajectories towards a more hybrid kind of environment. And specifically, one of the advantages of cloud native software development in general is the ability to run across multiple cloud environments, be it obviously on public cloud or obviously on premises as well. And the reason for that, if we look at the overall trend in terms of overall IT architecture, is it's definitely moving towards a hybrid world. There's no doubt about this. Actually, if I skip ahead, so this is where we asked respondents specifically about their plans for data platforms and analytics deployments. And as you can see, you see similar charts to this for all of the areas that we cover, different workloads. Currently on-premises, in blue here, is way ahead. Obviously on-premises, non-cloud is the predominant deployment location for, in this case, data platforms, but we see this in most workloads. Obviously looking ahead a couple of years, what happens is almost everything else is growing, or at least staying the same, whereas on-premises, non-cloud is declining. And so because of this, and this trend has been there since the last sort of 3 to 5 years, if you like, a lot of companies have sort of found themselves almost accidentally having a hybrid architecture because the workloads are being deployed. A lot of shadow IT is deploying workloads out into public cloud, different multiple cloud providers. And so they've discovered, accidentally ended up with kind of a hybrid environment. So going back to this slide, what we see is increasingly, significantly as well, with 62% of respondents here actively working towards a hybrid IT architecture, and actually more sort of deliberately, planfully putting workloads in place that actually enable this kind of environment. So to drill into a little bit more detail on containers and container management specifically, because this is where, obviously, as I showed, we see the greatest level of adoption of cloud-native technologies to date. Overall, we see the market's about $1.6 billion today, growing to just under $6 billion. So, compared to the overall IT market, still a very small slither of that, but with a healthy growth rate, over 25%, CAGR, over 28% actually, over the next few years. So it's a growing market. At this point, we say, specifically looking at respondents who are looking at containers, specifically 19% in use today, another 19% in discovery of proof of concept. So again, another proof point. This is an early stage market. The majority of respondents aren't yet implementing these technologies. But those that are, why are they doing that? And again, we're specifically talking to respondents here who have containers up and running. So again, these are actual proof points rather than intended proof points. It's about the standardization of the development environment, predominantly, over 55%. The isolation of applications is another key area of advantage, and portability as well. In terms of portability, this is one of those areas which is a theoretical advantage of containers, but similarly to what Nikita was talking about in terms of the complexity. Theoretically, this is something that can be gained, but you need to put up the upfront development work to ensure that is actually delivered in reality. Hence, we see about 30% of respondents actually not necessarily that confident in getting the portability, but a healthy amount, obviously 70%, being at least somewhat, if not very confident that will be achieved. As I said, it's something that it doesn't come for free. There needs to be that upfront focus in terms of enabling portability across those environments and actually planning deliberately for that rather than sort of stumbling into that hybrid environment. Another key advantage, and this is specifically in relation, in comparison, I should say, to a more sort of traditional virtualized infrastructure, is faster application resource provisioning. So we see respondents going from a full day in terms of resource provisioning down to hours, 26% going from weeks to days, another 20% going from hours down to minutes. So these are some of the key advantages, is actually obviously reducing that resource provisioning time, which can enable an overall reduction in the time taken in development and production and moving workloads, particularly into production environments. And again, compared to virtual machine environments, one of the key advantages being resiliency. So nearly 50% of respondents seeing improved resiliency from containerized architecture compared to virtualized environments. Now, this topic of resiliency is obviously a key consideration when it comes to the cloud native as it relates to data and analytics workloads. If we look at specifically data and analytics workloads, this is an area in terms of our surveys in relation to data and analytics users. We're just expanding this as an area of focus. But one of the questions we asked was to what extent organizations, this is kind of a softball to gauging the level of interest. To what extent organizations are considering or would agree that they're considering the use of, this is on-premises versions of cloud-native infrastructure. The question was a bit complex, so we trimmed it down for the slide. But basically on-premises versions of what would be considered a public cloud infrastructure. And you see 69% respondents agreeing to some extent that their organization is looking at that today. What's interesting is you look at, as I say, the most innovative companies, and in a data and analytics sense, we talk about companies being data-driven, and we always ask them to what extent they're making decisions based on data, to what extent they're data-driven. If we zero down on just the most data-driven companies that are making more decisions on average than others based on data, we see that jumps up to 78%. So again, indicative of the fact that it's organizations that are setting out on a transformational journey, trying to improve their their ability to deliver digital infrastructure, and to take decisions based on data that are ahead of the pack in terms of investing in these kind of technologies. And they're doing that in a number of ways. One of those in particular is machine learning, and we see, especially with, for example, TensorFlow and Kubernetes, and particularly the Kubeflow project, an increased focus on containers for machine learning, and the reason being that it gives developers the opportunity to package up not just the data, but the models and all the dependencies neatly in a container, which, back to the point about portability, can be used for testing, can be used for training, and then, in theory at least, can be the same environment can be used to take that workload into production. And this is an area that we see that a lot of organizations are struggling a little bit with in terms of machine learning at this point, in terms of going from data science experiments and development and testing actually into operationalization. So we do see the machine learning, containers has a potential advantage for those kind of workloads. In terms of sort of more, let's say, database, data processing, and analytics workloads, one of the things we've seen is containers today have been very successful, very useful for stateless applications. And very much, like this, you can create containers of applications, you can deploy them, you can move them around, you can, and they theoretically at least neatly slot together. Some of the challenges come in when there is the requirement to actually persist the state. And you see this with data processing workloads in particular, where obviously one of the great advantages of a container environment is that the container can be spun up and spun down, obviously, but if you need to persist the connection between that application container and the underlying data, that then becomes a lot more complicated. Kubernetes in particular, we've seen a lot of focus in the last couple of years in terms of emerging projects that enable the maintenance of state and better enable, I think we should say at this point, containers to be used for data processing workloads. Still very much a work in progress, and I'll come on to that, some of the areas around that in a second. But I think the reason why we see organizations really focusing on the opportunities around containerized or cloud-native architecture for data processing workloads is to do with a broader shift towards what we would call an abstracted data architecture. I think historically, we saw great advantage, obviously, from the tight coupling of compute and storage in terms of high-performance data processing. What has changed, and particularly this has happened particularly in relation, obviously, to the public cloud, but we see this also being reflected in private cloud deployments, is where a greater volume of data is being stored in that data storage layer, particularly in public cloud environments, and actually there's an abstracted compute layer which enables you, actually probably rather than, we should have illustrated here, rather than one compute layer, multiple compute services. So bring the compute to the data rather the other way around. And in particular, spinning up in-memory processing compute architecture to rapidly run multiple workloads potentially against the same underlying storage layer, the same underlying data in the storage layer. And it's this high-performance processing of data that we see, as Nikita mentioned, is one of the main sort of triggers towards what we call hybrid operational analytic processing, others call HOAP, etc. We're talking exactly the same thing Nikita talked about earlier. Essentially, running analytic processing on operational data. We talked about this last year. One of the things we've seen since then, we ran this survey just recently, over 50% of respondents are using, at this stage, hybrid operational analytic data processing, at least sporadically. Again, it's a technology clearly that's in the early stages of adoption, but we do see 17% respondents are saying they're actually using it strategically today. And I absolutely agree with Nikita that we anticipate much greater adoption of hybrid operational analytic processing over the next couple of years. This chart is worth explaining in detail. So if you look at, traditionally we've had obviously the OLAP database market and the OLTP database market. We see hybrid operational analytic processing. For us, we view that as a subset, really, essentially, of the transactional database market. And we do see it gaining a lot of ground. So this is in our anticipated revenue by 2022, about 27%. It's about 6% today. The key thing you need to take into account is we're talking about what we term here incremental database revenue or new database revenue. Because clearly much of the database revenue today comes from existing applications, existing workloads, which were never designed, to deliver this kind of hybrid operational analytic, very much traditional, transactional, or analytic. So if you look at it from that perspective, HOAP is a very, very thin sliver of that. But I think this is more reflective of where we see the trend going, because this is about the new workloads, new applications that are being developed and deployed. So just to finish off and conclude here, I mentioned earlier, obviously, we see a lot of focus on Kubernetes, in particular in relation to the ability to deploy and manage persistent database workloads in a containerized environments and a managed containerized environments. And we see, it's always a bit wary of sort of stating that something has won the market, but I definitely think we see a huge momentum towards Kubernetes in the last couple of years. Certainly from a vendor perspective, obviously from an end user perspective, in terms of the level of investment we see going in. A lot of vendors betting on Kubernetes as being the primary containerized container management environment for the next, at least, for the foreseeable future. Because of this, thinking about it from an end user perspective, when you see, pretty quickly vendors claiming support for Kubernetes, basically being table stakes. I think if you don't already see it today, within the next 6 to 8 months to a year, you'll see every company saying they support Kubernetes. But what does that actually mean? And there are, obviously different levels of support. And I think it's, will become increasingly important to zero in on what do you mean when you say you support Kubernetes. And again, this is an area where the CNCF is actually, particularly beneficial. I've taken this chart here from Operator Hub.io, and there you'll find details of operators that have been developed by organizations which enable the deployment of their technology and their applications on Kubernetes environments. An operator is actually particularly important for database-related workloads, because what it does is it packages up all the dependencies of the various services that are required to get whatever that application is deployed in a Kubernetes environment, and actually automate a lot of the manual effort that has gone on to date in actually getting a workload deployed. So you can see, this chart I think is really useful because you can look at the different operators that are available. You can see the level of functionality they're delivering, from just basic installation through seamless upgrades, full life cycle, what they call deep insights, and then all the way eventually to autopilot with horizontal, vertical scaling, auto-config tuning, abnormal detection, scheduling, tuning, etc. What's interesting, if you look at the number of operators that are currently available via Operator Hub.io or listed there we go. You see 17 that are currently in this phase 1, just basic installation. 4 that are offering seamless upgrades support. 17 again that are doing full life cycle. So I guess one thing to take from this is, if you're a developer and you're doing seamless upgrade support, you may as well go the next level as well. Seems that's what a lot of vendors are doing. But most importantly, only one that's currently offering what Operator Hub lists as being deep insights, which is metrics, alerts, log processing, and workload analysis, and currently none at the stage of autopilot. Obviously, as we will be watching this over the next couple of years, and I think you'll see not only these numbers increasing, but obviously we'll expect the numbers to increase further across towards phase 5. And this is where I think it will be increasingly important from an end user perspective, in talking to organizations that are claiming Kubernetes support, to be able to decipher what they mean by that and the level of functionality that's being delivered, and actually getting a good sense of the extent to which those products and services can actually deliver on the advantages of cloud-native infrastructure that we see that organizations are expecting. So with that, thank you very much for your time, and yeah, thank you.